Now we will have a lightning talk from Slava. Slava Krylov about EpiJudge, and your 5 minutes starts now.
Thank you. Hello, everybody. I would like to tell you about a learning project based on the book Elements of Programming Interviews. I'm one of the core developers. My main responsibility is to build and maintain the test framework that handles test execution, but more on this later. At first, there was a book, 3 books to be precise, and the main concept was to build a comprehension guide to small tasks that are usually asked on during programming interviews. The authors has a great expertise in interviewing, as they were members of selection committee at Google and Facebook. And no surprise, these books are Amazon's top seller in their categories. So each book contains more than 200 tasks and their solutions. And from very easy ones, like count the number of bits set in the number, to some upper intermediate ones, like regular expression matching. This project may be especially interesting if you're a programming teacher, or if you're a self-taught programmer that started to solve real problems right away, but didn't have much time to build a solid algorithmical background. But it's boring just to see the prepared solutions, and the best way to learn things is to try them. And that's what the authors and me help readers to achieve. What people get is almost all problems described in the book, but with the actual implementation stripped out and a main function added that can test the user implementation. It also does some other nice things, like the best one is that it's capable of guessing asymptotic complexity of the code. So let's see some example. Oh yeah. Sorry, wrong screen. So I hope it's to see. The problem is that on the input you have a string of parentheses, and you want to return true if every open parenthesis has a closing one and they're in the right order. I don't know if you can see, but the second string is ill-formed because there are no closing parentheses. So that's what you get right away when you download the project. You can see the function, but it has no implementation. It just has return true. And if we execute it, here, then we can see that we failed on the test number 5, and we can see the actual argument that caused the failure and the failure info. This problem is pretty simple, so here we can see only the expected result and what we've actually returned. But on other problems, there are much more info to know what's wrong. So let's take a look at the same problem, but with the implementation pasted in. Sorry. Yeah. So here you can see the actual implementation of this code. And if we run this program, then it executes all the tests. It passes all the tests, and you can see that the framework correctly guessed the asymptotic complexity of the code. It's linear to the size of the input string. So you can find the code. You can find the project at this address on GitHub. And thank you for your attention. That's all.
Thank you, Slava. Next up, we have Artem Zhukov about HVAC engineer and Python. So there's some kind of abbreviation. I hope it will be explained in the lightning talk. So what system is this? Lightning talks are a great place to learn about how to set up mirroring of displays on different operating systems. You can see it repeating endlessly, so Be sure to memorize that. Let's see. Is that it?
Yeah. Hello.
All right. Here's your 5 minutes.
Hello, everyone. Happy to be here. And what is fun is that if I would, somebody told me that I would be here 2 years.
Can you hold it
yeah?
closer?
Oh, okay.
Closer.
If I will be here giving a lightning talk 2 years ago, then I would say that you are probably mad. What is lightning talk? What is Pycon? I don't know. So I wasn't a Python engineer 2 years ago. I am HVAC engineer, which is heat and ventilation, air conditioning. And our company is quite typical one, so it's manufacturing company. It's like that, looks like that. And so we are building air handling units. But we started with the idea to make something good for people inside the building. So it looks like that. So this we made together with my friend. So we come up to idea to like how to make a building which really help us to be and we enjoy being inside, because now everybody see like it's hot, right? It's like not convenient, especially in another room. So this is what we are going to solve, and we realize that like with the conventional way how we're doing things, it's like completely inefficient. So one generation should come. So we started with the idea that okay, we have to write the software everywhere. Who can write software? Let's be engineers who is currently doing all their job in the Excel. So we had the Excel everywhere. And I started like, okay, guys, let's try to code in Python instead of Excel. It's going to be not complicated. So we started and we call it like 12 brave engineers. In around 1 month, we ended with 2 brave engineers, and just because of that, keep this letter T, because we like call it TB, like 12 brave engineers. And now we have only, in order to progress somehow, we were forced to have a remote team, because our engineers were impossible like to really write something which we're able to plug into the production. In first place, we start like doing like such things like Git, GitLab. So we had some consultants who help us to come up with some architecture which is like feasible and long-term sustainable. So a lot of new things. Now we found 3 engineers full-time, and we were really inspired by GitLab workflow and their way how they are like actually doing things so remotely. So we were prototyping a lot and validate with our clients. So for example, it's actually probably, yeah. This is a prototype application which we are validating with our clients. So it's like just a pictures, but it's possible to click. And we got like this way of development was totally new for us, and we got so many useful feedback which help us to tune our work at the early stages. So it was really useful. So everywhere new tools, complicated. And in 2 years, we were able to achieve a minimum viable product. And now we are progressing more or less efficiently. So we have a sprints of around 1 month, sometimes 2 weeks, and we are able to achieve. Even so that it could be overnight work with a pizza, but it's kind of fun. Yeah, and today I'm trying to contribute to open source. I made one open source project. I call it Pozemki, it's in Czech, you know, probably. And so my goal was like, I'm going to buy a piece of land. And the problem is that I have to always track websites and look and like where new properties were added, and this solves it in the way that you are just providing a website and some search string, and if it updates, it sends you a notification via Telegram bot. So it's here. So I would like really if you would help and contribute or just look and start using it. Thanks. I think it's, yeah, try it out, and this is it. Thank you.
Thank you, Artem. Thank you, Artem. Right, next up we have Petr Šebek asking the question, why to use async IO? Oh, you're already set up. You have 5 minutes.
Hello, please could you raise your hands who like to write slow and inefficient programs? Okay, right now I was going to say neither I, but as you wish. Okay, I am Petr Šebek from Quantline, and we do a lot of event processing, which means that we wait for some event, and then we do some computation and react on it. Usually on the internet, like we write something to database, or send something back. So, and we use async IO a lot, like in a lot of our programs. So async IO is a modern Python library for asynchronous programming. And here is an example what synchronous and asynchronous programming model is. In synchronous model, we can do only one thing at once. So we cannot wait for, has to wait for the response or for the return on some code. So if we send some network request, we need to wait all the time for the response. And then we can send another request, another waiting for it, and such. On the other hand, asynchronous programming model, we can just don't wait on it, and we can collect it later. So we send one request, then it goes back. We can send another request, and another, like 50 in air, and then we collect all the responses at once. It seems quite performant, yes? But how performant it is? To say the benefits of asynchronous programming, I like to use this analogy. It is analogy with human timescale and computer. So in computer, one CPU cycle can be compared to one human thought, like I add two numbers together or something like that. It could take me like 1 second, roughly. And you can see that in computer, this takes below nanosecond and 1 second for me. So one CPU cycle is done. But then we access main memory. It takes 100 nanoseconds for computer, and scaled for human, it would be like 4 minutes. It's like going through all your letters to see something you need. Okay, then you have SSD access, which is similar, but even slower. It's like 100 microseconds. And in the human timescale, it would take you some few days. And now we are getting interesting because we have internet call, which takes 60 milliseconds or something like that, below 100 milliseconds, which is quite fast, right? But if you scale it to the human timescale, it takes 5 years. So when we come back to the image with synchronous versus asynchronous, this waiting, like this, is taking several years. Several years of wasted time where your processor is doing nothing. Would you like to have a job where someone tells you, now waits 5 years to get a response? Someone do. Okay, so this is the way I think I can help you not to wait so long years for response and do some intelligent job. So please use async IO because we need a lot of new eyes, fix bugs in libraries because it's a wild west, quite. So thanks. That's all from me.
Thank you, Petr. Thank you, Petr. This one? Right, next up we have Martin Pavlásek with VCR. After that, would Jan Gazda and Joachim Čepický please go to backstage? Also, Lightning Talk speakers, when you go out, please collect your ebook vouchers. All right. Wow, that's some frantic action right there, connecting the computer. Is it HDMI? It's HDMI. It should be fine. It's not. VGA. VGA. It should still work, right? Okay. So we have 4 more lightning talks. All the speakers lined up in front. Wow. There we go. All right. So you have 5 minutes. Oh, not yet. Some magic button presses, cryptic commands. There we go. 5 minutes.
Hello. I'm Martin. I came from Brno, so I'm geographically kind of foreigner. But anyway, if you imagine days or ages about 15 years ago, and you are watching some TV series, and for some reason you couldn't catch it because you are at home, or not you are at home, but you are at work or at school, you probably use some device like this, the big one, this video cassette recorder. And by the time it gets too old and some discs like DVDs and Blu-rays came, but still, VCRs can be pretty useful also by these days, also in Python. It's actually the tool that you can record some usual API requests and save it as a file and use it afterwards, even you don't have internet connectivity. I was searching for some APIs that I can send or ask for some huge payloads that will take a long time to process, but it's turned out that it would be better to create some simple server and put some sleep. Let me adjust the screen. Anyway. On the left side, you can see a pretty simple script that will just ask for some localhost port to connect. And on the right side is very simple HTTP server to just serve some data. I will run the server. And if I run the script that will just ask for the content, it will take some time because there is sleep for 3 seconds. And in case that you want to test it and you don't want to spend a lot of time just waiting for something, you can use VCR to save that content. So just import VCR library, and you can use it as a context manager. So with VCR dash use cassette and put some file name. And run it again. Oh. It still takes, it takes some time. But if I run it again, it's processed almost immediately. Because there is new file, which is called reds.yaml, and that's actually the content of the request. There's everything like headers, and actually the body that we are looking for. So it's you can use it in testing, but for the last time, I used it actually during traveling because I was in train for more than 2 hours, and I wanted to do some hacking without internet connection. So I just record everything. Yes. So I just record everything to this YAML file and work offline, and it works pretty well. Thank you.
Thank you. All right, that was Petr Šebek. That was Martin Pavlásek, sorry. The lines get mixed up. Next up should be Jan Gazda. Do we have a Jan Gazda with a presentation on OpenVPN config automation? All right, so who here knows what OpenVPN is? Who uses it regularly? Oh, not that many people, but it'll be interesting to all of those who had their hands up. I hope, at least. All right, so we have the mirroring dance again. I feel like I have backstage access here. Ah, there we go. Is that it? All right. Your time starts now.
Hi, everyone. Peter stole a few questions from me, so I'll start with my next question. How many of you are doing any ops works? Yeah, I see some hands. So you probably know what is it to manage OpenVPN certificates without any other tool than just EasyRSA. And EasyRSA is a lovely tool written in Shell, and it has only 1,331 lines. And it's basically a wrapper around OpenSSL. So I had this idea. Our user base was growing, and we wanted users to create their OpenVPN configs. OpenVPN config looks like this. It's basically a config file which every client needs. It contains some basic configuration, then CA certificate, client certificate, and client key. And client key and client certificate are client specific, and every user should protect client key with a passphrase. And we didn't want to provision any passphrase because it's not secure to distribute for passphrase, and we wanted to let users to decide about their own passphrases. So my idea was, okay, let's write something simple in Python and just wrap EasyRSA and create a small, simple Django application to let people to just register themselves. Well, it worked till the point we decided to try out wrapping EasyRSA. It turned out that there are so many confirmations and so many pops up during the process of EasyRSA, which you cannot catch with a popen and other tools. So another thing, another idea was that we have to rewrite the functionality of EasyRSA. So I was reading this file and learning how it works. So I created this small project. It's called a PyOpenVPN EasyRSA. The name is not so good. If you want to contribute and come up with a better name, I'm all for. And what it does, I'm using a simple cryptography module. You could use also PyOpenSSL, but they discourage using PyOpenSSL for working with the certificates. So I used plain cryptography, and I basically written a few functions to simulate what exactly EasyRSA does. It doesn't took me that long. I had to learn stuff about certificates, and that was the longest part. But in the end, these utilities is just 400 lines and does all I need, and now it's basically pluggable into any application you are using. If you are willing to contribute, I would like to add also some useful CLI. I didn't have time yet, so I'm welcoming every contribution. Thank you.
Thank you. Thank you. All right, next up we will have Joachim Čepický. I would like to ask Miro Šedivý to go to backstage to prepare, and also Lumír Balhar and company. I think you're already there. All right. So Joachim will be talking about PyWPS. I wonder what that is. Does anybody know the PyWPS? Pretty much nobody, so you will all be enlightened. Is that what you want to show us? Something about shoes? Shoes for Pythons? All right. This should work. All right. Here's your 5 minutes.
Okay, thank you. Hi, make it visible. My name is Joachim, and I would like to introduce you PyWPS as a project and share my happiness with you at the end of this lightning talk. So what is PyWPS about? PyWPS is the Python implementation of OGC web processing service on the server side. Apparently, nobody here knows what web processing service means or what OGC means, but it is related to geospatial, to GIS. And the web processing service standard is about how to tell the server to make the heavy calculation on the server and return back some result. In the field of geospatial, we are processing usually gigabytes of data. It takes time. It takes resources, therefore it makes sense to move it from desktop to the server, and this is what this WPS or Web Processing Service standard is about, and PyWPS implements this standard. PyWPS started the development in 2006, so it's now 12 years old Python project, still living, and just last month, PyWPS was incubated, and this is why I'm so happy, and this is what I'm sharing here with you, is incubated as OSGeo project. And what is OSGeo? OSGeo is the open source geospatial foundation, and we try as a non-governmental organization to cover the topic open source software for geospatial. So now PyWPS is among some of the projects which are already incubated in the past time. The incubation took 9 years, so quite a long of time, and we are happy it's behind us. That's all. Thank you.
Right. Thank you, Joachim. And now we will have a lightning talk by Miro Šedivý with his super fast setup. Here you go.
Thank you. Hi everyone. I don't have my keyboard or my computer with me because I want to see your computers. Who here is using the standard US keyboard layout? Is their working setup? Great. I like this keyboard layout very much because it's so simple. It allows me to program in Python, in other programming languages very well, and even to type in English or in a few other languages quickly. There are no more than 2 characters per key. It works very nicely. Ale funguje to jenom do momentu, do okamžiku, jak potřebuje napsat svoje příjmení, co je Šedivý, s háčkem i s čárkou. Na to potřebuje českou klávesnici, která má čárky, háčky, ještě jiné znaky, kde se čísla dělají se shiftem a která je kverc namísto kverty. Ale to si pak musím zapamatovat jiné rozložení klávesnice. Das funktioniert auch mit der tschechischen Tastatur, wenn man aber jetzt auf Deutsch schreiben will, das heißt mit ein paar Umlauten, Ü und mit dem scharfen S, Da braucht man wieder die deutsche Tastatur, die ist auch querz und die vielen anderen Zeichen, die sind wieder woanders und man muss sich das auch alles merken. Est-ce qu'il y a quelqu'un déjà ici qui a déjà écrit sur un clavier français? QWERTY, c'est AZERTY. Le M, il est totalement ailleurs. Le point, on le fait avec un shift. Tout est totalement ailleurs. Mais si on veut déjà écrire avec CEDI et quelques accents circonflexes aigus, etc., ouais, mais sur le clavier français, ça fonctionne. Mais il faut l'apprendre. Slovenská klávesnica sa podobá trocha českej. Tam napríklad meké L, ne, L, U s kroužkom tam teda nie je, no a teda podobá sa do česky, lenže zase keď som napísal niektoré slovenské veci, tak potrebujem slovenskú klávesnicu. El teclado castellano ya hemos visto, si necesitamos tilde o signos de interrogación o de exclamación abiertos, necesitamos el teclado castellano. Klawiatura polska jest bardzo podobna do klawiatury amerykańskiej. Z tą różnicą, że jak chcemy jakieś ogonki, kreski, kropki i chcę pisać, że kogoś do się nazywa Grzegorz Brzęczykiewicz i mieszka w Chrzącie-Żewošice pod Jadwinkowody, jest potrzeba polskiej klawiatury. La tastiera italiana è abbastanza facile, con la differenza che se voglio scrivere le lettere accentuate maiuscole non posso farlo con shift perché ci sono altre lettere maiuscole accentuate. Po svenska använder man A-medring, a magyar ABC-ben kettős L és EKZ található is. Kvankam Esperanto estas internacia lingvo, ankaŭ ekzistas tre specialaj literoj. Ve türkçe de büyük noktalı I, ve küçük noktası ivar. And we have only scratched the surface. So anybody who is just writing in a few European languages has already the problem that the keyboard layout is just totally different in every of these languages, and you have to remember if you want to program all these special characters that just wander all around. What I discovered a few years ago and what I am using every day, because every day I'm just typing in a few European languages, is the compose key. So any operating system you are using, just Google for the name of your operating system and compose key, and it allows you to type sequentially. So if you can't play piano or type in Emacs, you just need really one finger or two fingers. Compose key and then two other characters that are very intuitive to learn them. Anybody who would like to see how it works can ask me afterwards. I will be happy to show you and help you to set it up. If you want to hack your keyboard layout, whether you are using the Czech one, German one, or the English one, US one, to the maximum, you can even hack your your caps lock, because you don't really need it. And I can show you how to use your caps lock as a control and escape key at the same time, because usually when you hit control, you press control and press something else. Escape, you always hit it only. So it means your caps lock, you can set it the way that pressing and holding it will allow you to use it as a control, and just hitting caps lock will serve you as escape, which works perfectly well in the standard. No, it's not standard. Standard editor is add, but for example, in the VI editor. That's everything. Thank you very much.
Thank you.